Hi mathletes, this is going to be a short video lesson about systems of equations where we focus on how to solve them by graphing.
We're going to start with the scenario where Kimmy and Jordan are working during the summer to earn money in addition to their weekly allowance, and they're saving all of their money. Kimmy earns $10 an hour at her job, and her allowance is $8 per week. Jordan earns $8 per hour, and his allowance is $16 per week. Let's start by filling in our table, our top table for Kimmy. And remember, Kimmy earns $10 per hour, but she makes also $8 per week. That's just a once a week payment of $8. So if she doesn't work any hours, she's going to get that $8. If she works 1 hour, she's going to get $18 because she's going to get that $10 per hour, plus she's going to get the 8 for the week. So that's 18. If she works 2 hours, she's going to get $20 from her job plus the $8 that she started with. So that's going to be $28. And we'll fill in the rest of our table. You might notice that we're really just adding 10 as we go from the number of hours. So we'll fill in the rest of the table. Now we'll look at Jordan's table. And remember, Jordan earns $8 an hour, and his weekly allowance is $16 per week. So if he doesn't work any hours, he is going to get $16. And then to add on to his rate, he's getting $8 for that extra hour. So 16 plus 8 gives us the 24 that we already had filled in. And you can keep adding 8 here to fill in the rest of the tables for his hourly increases. We can represent this information by an equation. So for Kimmy, her weekly earnings would be K equals, and we can think of our slope here. And our slope is this, what we're increasing from each hour. So our rate of change, or our slope, is increasing by 10. So that's going to be 10 times the number of hours earned. And we're going to add to that our y-intercept, which is our starting amount, which is the weekly allowance, that one-time fee. If we look over for Jordan's equation, his weekly earnings is going to be J equals, now his slope, or his rate of change, is increasing by 8 for every hour. So it's going to be 8 times the number of hours plus his y-intercept, or his starting value, which is 16, that weekly amount, that one-time amount of 16. We can also sketch out what this scenario would look like graphically. So please take a moment to do that. We have the hours along the x-axis. We have the money saved along the y-axis. And I just did a quick sketch here. I put in all the points, but you really could graph the intercept and then that point of intersection that they have here at 4 hours and 48. And you can see that in the table as well. What this is showing us is right here, Jordan is making more money. So from 0 hours until 4 hours, Jordan is saving more on that hourly amount. But after 4 hours, he starts making less because of Kimmy's higher amount per hour that she's making. And so that's when Kimmy starts being able to save more if she works more than 4 hours. So if you look at this question down here, Jordan wonders who will save more money in a week if they both work the same number of hours. Write an explanation for Jordan. And it really depends. And that's shown by the graph, and you can even see it in the table. So write a quick explanation that if it's less than 4 hours, then Jordan is making more. If it's more than 4 hours, then Kimmy is now making more. And at 4 hours, they break even and they save the exact same amount. That example could be considered a system of equations because it is 2 or more equations with the same variables or the same context. A solution to the system of equations are all coordinates that satisfy all equations in the system. This is essentially the points of intersection, any points of intersection between the graphs. In order to solve a system by graphing and to identify the solution, we'd simply graph each of the equations that are given to us on the same coordinate plane and then look for any points of intersection. So we have to think back to slope-intercept form. And when we have y equals 3x plus 1, the coefficient of x is our slope. So I'm going to put that over 1, so I have my rise and my run. And then the plus 1 is my starting point on the y-axis. So I'm starting here at 1, and I'm going to go up 3 over 1, and I'm going to do that and then connect that with a line. Now we're going to do the same thing with the second equation on our same graph. So we're looking at our coefficient of x, and when there's no number there, I can put a 1, so that's a negative. This is going to be negative 1 over 1, and my starting point is 5 on the y-axis. That's right here, and then I'm going to go down 1, right 1, down 1, right 1. You can see I already know what my point of intersection is. It's hitting right here, but let's connect the line. So we can see right here is our point of intersection. That is at an x value of 1 and a y value of 4. So 1, 4 is the coordinates. So 1, 4 is what we're going to write on our line for our solution to the system. It is the one point that these two lines share. That's their point of intersection, and that is the solution. Now let's graph the next two lines. Pause here to graph them on your own. To graph this top line, we started at 4, down 2 over 1, down 2 right 1. To graph the bottom one, we started at negative 1 on the y-axis, and then again down 2 right 1, down 2 right 1. And when we connect these, what do you notice about these graphs? There are no points of intersection, so we would say there are no solutions to this. No solutions always occur when you have parallel lines because they have the same slope and different y-intercepts, so they'll have no points in common. Now we will graph these two lines. Pause here to do that on your own. We start with graphing this top line. We start at 3, and we go up 1 to the right 2, up 1 to the right 2, and I connected that with the blue line. When I got to the second line here, I started at 3 again. I had the same y-intercept, and up 2 to the right 4 lands on the same line. So the red line or the second line would totally overlap on my blue line. And so every point of intersection is the same. And so we say that is infinitely many solutions. Again, we have infinitely many solutions when the lines are overlapping. It's really the same line, just written in a different form perhaps, and they have the same slope and the same y-intercept. So these three examples have shown the three different scenarios that two lines can have. They can either intersect at one point, at no point, so they are never intersecting. Those would be parallel lines to have no solution. Or they can have infinitely many solutions because they're overlapping lines, which are really the same line, just in a different form. What if you have a system of equations like we have here that are not in slope-intercept form? We are going to solve for y first. And so we'll have to go and use our algebra skills to get our y by itself. So I'm going to take that first equation, and I want to get this y by itself. So the first thing I'm going to do is I'm going to subtract 4x from both sides to get this to cancel out. Now I have negative 2y on the left. Now, negative 6 and 4x x are not like terms, so we cannot combine those. So I'm going to put the negative 4x first and the minus 6 next to each other. I put the x first just because that looks more like slope-intercept form. And now I'm still trying to get y by itself, and I'm multiplying that negative 2 by y. To undo multiplication, we divide. So I'm going to divide every single thing by negative 2, and I'm left with y equals negative 2 divided, or negative 4 divided by negative 2 is positive 2x, and negative 6 divided by negative 2 is positive 3. So this is my new equation that I'm going to graph. So I'm going to start on the y at 3, and my slope is 2 over 1, so I'm going to go up 2 over 1, and then I'm going to use my straight edge to connect those points. Now I'm going to do the same thing for my other equation, negative 2x plus y equals 3. It's trying to get that y by itself. To do that, I'm going to get rid of this minus 2x, so I'm going to add 2x to make that net out to 0. So on the left side, I just have y left because the negative 2x plus 2x nets out to 0. And again, on my right side, these are not like terms, so I could really write them in either order. I'm going to put the 2x first and then plus 3, so it looks more like slope-intercept form. And we are going to start by graphing 3 on the y, which is right here. And look, my slope is exactly the same as it is for my blue equation. So they both have a slope of 2. So if I go up 2 over 1, I am lying on the same line, so that red line would totally overlap my blue line. So again, with overlapping lines, we say that this is infinitely many solutions. With our next set of equations, take a moment to graph those. Pause here. I wanted to put this into slope-intercept form again, so I needed to get the y by itself. I subtracted x from both sides, so I had 2y equals negative x plus 6. I wanted that x first just to keep it in the form we're used to. 2y is 2 times y, so to get rid of that 2, I divided everything by 2. And negative x over 2 is the same thing as negative 1/2 x, and that's just easier for me to see my slope. 6 divided by 2 was 3, so that was my starting point. So I started right here at 3, and I went down 1, right 2, down 1, right 2. Now this other equation, this mini equation, x equals 2, is one of our special cases. That's a vertical line. I went to the x-axis at 2, and I drew a vertical line through that point. And so we can see right here, this does have a point of intersection. It happens to be at 2, 2, and that's what we'll write on our line. Take a moment to pause and plot these last two equations. My top line was already in slope-intercept form, so I just needed to look here, and because it was just 3x, y equals 3x, there is no value being added or subtracted, so I can think of that as 0. So I started here at 0, 0, and then I went up 3 to the right 1, up 3 to the right 1, and connected that with the line. For my second equation, I wasn't in slope-intercept form, and so what I did was just get the y by itself. I subtracted 4x from both sides, and I got y equals negative 4x minus 7. Negative 7 was my starting point right here. And then I went down 4 to the right 1. That was kind of off my graph, so I decided to go up 4, and then that meant I went left 1, and I could keep going up 4, left 1, and then I used a straight edge to connect my points. And you can see my point of intersection was right here, so these two lines have one solution, one ordered pair, and that is at negative 1, negative 3. That is the solution to this system, negative 1, negative 3. Super quick summary: to solve a system by graphing, you first graph each line on the same graph, then look for a point of intersection. If there's a point of intersection, you're going to write that as an XY ordered pair. If the lines never intersect, there is no solution. And if the lines overlap exactly, that means there's infinitely many solutions.